We're moving on to the next chapter. We're on circles now, and the specific section is on arcs, angles, and tangents. So to preface this chapter, there's lots of definitions, rules, and stuff that you need to remember. And that just builds on top of the other topics that you learned in the other chapters, like polygons, triangles, and angles, rays, vertical angles, parallel lines, all those other things. You also need those concepts and definitions and rules here as well. So this is where geometry gets harder, when you're combining a bunch of different topics into one singular problem. So hopefully these videos can be of help as you watch and maybe learn how I think through the problems if you're having trouble with these. Okay, so with that said, let's begin. I'm not going to go over the definitions this time, there's too many. So maybe I'll go over them as I do the problems though. Okay, so we are given this figure. In the figure of BD is a diameter. PA and PD are tangent to circle O. CDE is 52. Yep. APD is 45. They labeled that. AP is 9. Okay? Okay, now let's begin this beast of a problem. What is the measure of ODC? Where is ODC? ODC is over here. How in the world would we get that angle? Well, the key is this DP or PD is tangent to the circle. When it's tangent, it's perpendicular at that point of tangency. So this angle here is 90 degrees. And as a result, this entire angle over here is 90 degrees as well, because this angle plus this angle is 180. Okay? So this angle here is 90. So this is the angle of interest over here. So it's 90 minus 52. And what's 90 minus 52? That's 38. The idea here was, again, it's tangent here, so it's a right angle. And then you had to be able to see that this angle, or you can say this angle plus this angle plus this angle equals 180. So that's how we solved it. What's the measure of OCD? Not ODC, OCD. So this is where the names of the angles matter. OCD. How in the world did we get that angle over there? Well, notice that this is a radius and this is a radius. These two sides are congruent in this triangle over here. Okay, you have to be able to see that. This is, again, this is where it gets tough. You have to know what a radius of a circle is. So these two are both radius, and then you realize this is a isosceles triangle, number 2. Number 3, if it's an isosceles triangle, then this angle is congruent to this angle. Okay, this angle we just found was 38, therefore this angle OCD is also 38. Okay, so really not hard, but you have to be able to see those. You have to have those other concepts as well. What is the measure of AOD now? AOD, what is this angle here? Well, one way I see right away is this is a quadrilateral, ODPA. So what's the sum of the angles in a quadrilateral? 360. We know this angle is 90 degrees, and so is this angle, because PA is also tangent. So that's 180. 360 minus 180 is 180. So this angle plus this angle must be 180. So AOD is 180 minus 45 degrees, which is 135. Okay. And finally, what's the length of PD? Where's PD? PD is here. This is the length. Okay. If you make a good guess, it's probably 9. And there's a theorem, I believe. If it's a theorem or a rule, I don't remember, but I do remember this thing that if there are 2 tangents to the circle and they're intersect at the same points, then the lengths are the same. Okay? So, since this is 9, this guy is 9 as well. There's a theorem or something, or a definition, something like that. So that's 9. Okay? As I said, there's lots of things for circles, so I would recommend you review them before attempting these problems. Maybe actually this is out of order. Let me go to the lesson and see what the terms are. Like radius, a chord, a secant, a tangent, point of tangency, central angle, major arc, minor arc. I don't think those are too important. Semicircles, half of a circle. And there's the arc addition postulate. And then there's that theorem I just said where those two are congruent. Okay? All right. Now let's go back to number 5. In the figure above, circle O is inscribed in triangle PQR, okay? PA is 12, QA is 6, RB is 9.5. What is the perimeter of PQR? Okay, so we need the lengths of all 3 sides of the triangle. Can we get this length over here, BP? That we're missing that, right? Well, this is tangent to the circle, and this is also tangent to the circle. Okay, it doesn't explicitly say it, but it only touches the circle once there. So it's tangent there, okay? The angle it would make with the radius is 90 degrees, but we don't need that here. So this length over here is 12 as well, okay? Now what about over here? Well, we can use the same idea here. This is tangent. This is also tangent from the same point. So that's 6, and similar for this. This is 9.5, okay? So let's add this up. What's 9.5 times 2? That's 19, right? Plus 24 plus 12. And what is that? That is 19 plus, that is 36, right? Which is 55. Answer is D. Okay? So we used that theorem a bunch of times. Okay, last one in the set. In the figure above, OP is a radius and PQ is tangent to the circle O. If radius of circle O is 10 and QR is 16, what is the length of PQ? This is actually really easy. Okay, so this is a radius. This is also a radius. So this length is 10. And now we can use Pythagorean theorem. Hypotenuse squared is this side squared plus this side squared. How can we know that it's a right triangle? Well, by definition, tangent. So it's a right angle there, so we can use the Pythagorean theorem. So this is 26 squared minus 10 squared is PQ under the square root over there. Okay? And what is that? If you put it into the calculator, it should be 24. Answer C. I don't know if they expect you to know 26 squared off the top of your head, but it's not too bad either if you do it. Okay? And that's it for this practice set. So you can see I quickly went through it, but it's because I have those small details from other chapters. I know them well. I'm quite fluent in them. So that's how I was able to see and think through like this problem especially. Okay, this one was not too bad. It just kept using one idea. And this one, I knew the Pythagorean theorem right away. So again, you need to know previous topics as well. In a lot of geometry problems, they combine a lot of topics into one, and you have to be able to problem solve it. Okay? As always, please like and subscribe if you found this helpful.